This is the lesson for Mat 6, Lesson 2, Special Right Triangles, 45, 45, 90 triangles. The goal of this is going to, again, be solving for sides of right triangles. So in the previous video, we saw solving with Pythagorean theorem. So when you have two sides of a right triangle, we can use that property to solve for the third side. With 45, 45, 90 triangles, we can use this if it's something we can't do with Pythagorean theorem, but we know the angles are 45, 45, 90. They're going to follow a certain relationship. So our goal is going to be using 45, 45, 90 triangles to find side lengths. So a 45, 45, 90 triangle is named after the angles of a certain right triangle. So we have a right angle, and then the two angles, acute angles, are both 45 degrees. This actually makes a right isosceles triangle. So the two legs are going to be the same length, and the two acute angles are both 45 degrees. So what we find that if we had done Pythagorean theorem to solve, we would actually get the same relationship or ratios for the sides. So the two legs are going to be the same length for this specific triangle, and then the hypotenuse, which again is our longest side, is going to be the side length times radical 2. So if k was our scale factor, I can find all of the sides of a 45, 45, 90 triangle just by knowing one of the sides. So our steps we're going to use for solving today is we're first going to label, once we identify it's a 45, 45, 90, we're going to label the sides of the triangle with the corresponding ratio. So again, the two legs are going to be, for this, we're going to label with K, but you can use any letter you like. And the hypotenuse is going to be labeled with K radical 2. We're then going to set whatever ratio corresponds to the value they gave us. We're going to set those equal and solve for our K value or our scale factor. And then we substitute that in to find the remaining sides. So for these examples where we identified that these are 45, 45, 90 triangles. So really what we're doing is we're using similar triangles to solve. So for a 45, 45, 90, and again, 45 are the degree, I know that the legs are going to be the same. So if I call the first leg is some value k, I know the second leg is also going to be k. And then the hypotenuse is going to be k radical 2. And again, you can use any variable you like. I'm just using k for scale factor. So our first step is we're going to go ahead and label our ratios out. So if I look at the two legs, they form the right angle, I'm going to call both these K. And the hypotenuse, which is across, I'm going to call K radical 2. Right? So our first step is we're just labeling our ratios. Now we're identifying the side length they gave us, right? So again, I could do Pythagorean theorem knowing these are both 14, but this ends up, when you get the hang of it, ends up being a little faster for the 45, 45, 90. So I can see 14 is the same value as K. So if I set them equal to each other, I have K equals 14. There's nothing really to solve there. K is already by itself. So my scale factor essentially ends up being 14. So now wherever I see the variable k, I'm substituting in 14. So I get 14 radical 2 for my hypotenuse. I'm putting in 14 in for k. And this ends up being the remaining two sides that we're trying to find. So our goal was to find x and y. I can see that x is equal to 14 and y is equal to 14 radical 2. And that would be my final answer. The second problem is done essentially the same way, so we're still using this similarity with the special right triangle. So I'm going to go ahead and label this out. So my two legs that form the right angle for 45, 45, 90 are the same, so I'm going to call both these k. And my hypotenuse is k radical 2. I'm then going to identify the value they gave us and set it equal to the ratio. So I have here k radical 2 the same color. K radical 2 is equal to 5 radical 2. And then you're going to see for this one, unlike the previous example, k is not by itself. I'm going to have to solve for k. So k and radical 2 are being multiplied. So I'm going to divide by radical 2. If I multiply by something, I could just divide it off. The radical 2's go away, so I'm left with k. And then it just so happens radical 2 divided by radical 2 also goes away, so I'm left with 5. So my value, or my scale factor, is 5. So now wherever I see a k, I'm going to put a 5. I don't have to put it back into this one because I already knew this was 5 radical 2. So I don't have to do that. I know that we have a 5 and a 5 here. So those would be my solutions. So I have that x is equal to 5 and y is equal to 5. In this next example, we're still solving for the sides of a 45, 45, 90 triangle. So they give us one of the angles is 45 degrees. The other angle is 90 degrees. Obviously, if we subtract from 180, we know the remaining angle is 45. And so we can solve this using properties of a 45, 45, 90 triangle. So I'm going to go ahead and sketch our similar triangle we're going to use. So I have 45, 45. I'm going to call them the two legs k. And the hypotenuse is going to have that k radical 2. So our first step is we're going to approach it just like the other problems. The only thing that's a little different is you might have to use some properties with solving with radicals, which isn't anything too different than what we've done in different mods. So the first thing is when we label this out, we see we have our right angle. And we know the two sides that form that right angle are going to be our legs. So I know I have a k, and then the side that's opposite the right angle is going to have that k radical 2. So our first step is labeling it out. We're then going to see the valid length they gave us was 3 root 2, which pairs up with our ratio of k. So if I set those equal, I have that k is equal to 3 radical 2. We don't have to do any additional solving here because our scale factor is already solved for. We know it's k radical 2. So now wherever we see the variable k, we're going to substitute in 3 radical 2. So the other leg's pretty easy. You know that's just going to be 3 radical 2. Where it gets a little tricky is when we put it in and have to multiply now that 3 radical 2 by radical 2. So again, I just substituted that in. So our answer is not just 3 radical 2. We have to go ahead and simplify. So radical 2 times radical 2. Some of you might remember when we learned radicals that just becomes a 2. If you need to see it again, you know that's 2 times 2, which is 4. The square root of 4 is 2. And so the hypotenuse is actually 6. So we actually get then our answers here are going to be x is equal to 6 and y is equal to 3 radical 2. I don't have to solve for that third side. They already gave it to us. And that would be your answer. In this next example, we're going to do the same thing that we did before. This is a 45, 45, 90 triangle. We're going to go ahead and label our ratios out. So I have k, and k radical 2. And we're going to go ahead now and label this. So we have a k, and a k radical 2. We're then going to identify the value they gave us. So we have an 8. And we're just going to set those equal to each other. So k radical 2 is equal to 8. Unlike the other problems where k is by itself, this one we're going to have to solve for it because it's getting multiplied by radical 2. So if we divide both sides by radical 2, we get k equals 8 over radical 2. And if we might remember that we can't leave our answer like that, we have a radical 2 on the bottom. So we're going to actually have to rationalize this out. So remember, anytime you have a radical on the bottom, we have to get rid of it. So I'm going to multiply the top and bottom by radical 2. On the top, I have 8 radical 2. On the bottom, radical 2 times radical 2, 2 times 2 is 4. So 8 radical 2 over square root of 4 is 2. And then the values outside, the 8 and the 2, you can go ahead and simplify. So this becomes 4 radical 2. So we end up getting our k value is 4 radical 2. So now wherever we see a k, we can substitute in 4 radical 2. So actually, it just works out that both of the legs are going to be 4 radical 2. So that means x is 4 radical 2 and y is 4 radical 2 because those are both the legs. In our last example, again, same thing. The only thing that's different is we're just doing some different properties of radicals. So if I look at my 45, 45, 90, I know the legs are k radical 2. And again, we just go ahead and label it out. So our two legs are going to be k. Our hypotenuse k radical 2. We set the value equal to the ratio. So same thing as before. Like the last problem, I have to divide by radical 2 because k is not by itself. And then similar to the last problem, I have to rationalize. And so when we rationalize this out, I have to multiply the top and bottom by root 2. So for the top, root 3 times root 2 is root 6. So you multiply them. On the bottom, I get root 4, which is 2. And then when I simplify, I get 2 radical 6. So wherever I see a k, I know that's 2 radical 6. And so from here, you would get then the answer for n and for m. So n is 2 radical 6. M is 2 radical 6. If you have questions from the notes, please make sure you're asking questions in class, during T-Bolt time, or in the center. You do need to complete the U-tries to receive full points for these video notes. So when these are checked in class, you do need to make sure you have your U-tries completed to receive full points. So again, the remaining problems from this section need to be completed. Even if they're not perfect, we need to see that you're trying the steps out before you come to class so you're ready to ask questions. All right, thank you very much and have a great rest of the day.